Good morning. I am Dr. Singh Ojha, Assistant Professor in Department of Electronics and Communication Engineering. Today I am going to discuss voltage to current converter and current to voltage converter, as well as one more topic, that is instrumentation amplifier. So let us begin with voltage to current and current to voltage converter. Actually, current to voltage converter is the circuit which can convert current into equivalent voltage, and voltage to current converter is the circuit which can convert the V2I means voltage into equivalent current, and I2V means current into equivalent voltage. So let us see, the voltage to current converter is a electronic circuit that converts an input voltage into a proportional output current. And purpose of V2I is these converters are essential in creating stable DC current signal for analog representation and physical quantities. So generally, operational amplifier is implemented to convert voltage into corresponding current. Now let us start with one circuit, and its name is floating load voltage to current converter. Floating load, you can see here, this is operational amplifier. This is the voltage source which is connected over here. This is one input resistor, and this is actually load. This load is not connected to ground. That's why this circuit is known as voltage to current converter, but with floating load. Floating load means load is not connected anywhere to the ground. So now the process of analysis of this circuit is very simple. That means we will see the current which is flowing here in this branch will equal to the current flowing in this branch, because no current will enter into the input side of this operational amplifier. So now you can see it that the current which is flowing through resistor RL will be the V naught minus the potential of this point, that is by virtual short circuit it will be equal to V in. If I will write it as Vx, then I can write this current IL is equal to V naught minus Vx divided by RL. And what is Vx? Vx is nothing but it is V in. So you can simply write it, and if I will talk about this II will be equal to what? V in minus 0 upon R. That means this Vx minus 0 upon R, and Vx is nothing but it is V in. So II is equal to V in by R, and II is equal to IL. So you can write this value, but there is no need, because then whatever you are going to achieve will not achieve. So you can you can put directly it as IL. So you can directly, now you can write IL is equal to V in by R. And now you can see it that output is the current IL, the load current, and V in is the input resistance, input voltage. So now you can see that this circuit is converting this input voltage into the equivalent current IL, which is equal to V in by R. And now you can see here the next circuit, and this circuit is again voltage. We are applying voltage and we are getting here the current. So this is again voltage to current converter, but with grounded load. Now you can see here that this load is grounded. In previous case, this load was not grounded. This load was connected between output and this terminal V2, but now it is connected to ground. So, now let us analyze this circuit. Simply we can see how we can analyze this circuit. To analyze this circuit, we need to know this voltage V1 and how we can find out this V1 just by applying voltage divider rule. We need this V1 because V1 is equal to V2. That's why we need this. So, how we can analyze? We can see here the current, this I1 plus this I2 is equal to IL. So, what is I1? I1, you know, I1 is V in minus V1 upon R. I2 is V0 minus V1 by R. And this IL is what? V1 by 0 divided by RL. So, this is what written over here. So, if I will take LCM, I will go there, and in this way we can proceed to this next step. Now, you know, if once you came to know the value of V1, and this is actually non-inverting amplifier because we are applying input on positive terminal, that means non-inverting terminal, and the gain of non-inverting amplifier is 1 plus RF upon R1. This is V0 upon Vi. That means I can simply say that this is the gain. So, if you will analyze this circuit again, so you can say this. So, here you know RF and R both are same. So, if they are same, that means this gain will be equal to 1 plus 1, that means it will be equal to 2. So, if we will put V0 is equal to 2V1, and which we have already find out, V in plus V0 minus ILR multiplied by 2 divided by 2, it will be cancelled out. So, you can simply see that IL is equal to V in by R. Again, what is V in? V in is the input voltage. And what is IL? IL is the load current or output current. So, you can simply observe here that this circuit is converting this voltage into current. That's why its name is V2I converter. V2I converter. And that too with grounded load. That means load is connected between one terminal that is connected to output and ground. Now, what are the applications? We have studied voltage to current converter. What are the applications of these circuits? One is Zener diode tester, low AC and DC voltmeters. They are used in testing of LEDs. They are used in testing of diodes. So, these are few applications of voltage to current converter. Now, we can see one more type of circuit, that is current to voltage converter. A current to voltage converter or I to V converter is an electronic circuit that takes current as an input and produces voltage as the output. So, in this section we will discuss current to voltage converter. However, this circuit seems to be very simple, but sometimes it may be complicated depending on the application. But simply we can understood by this example. We are considering that we have current source, and this current source is connected in this way to the operational amplifier, and here we will get output voltage. So, now if you will see here, this current II will be equal to what? The potential of this point, that is Vx minus this V0 upon Rf, and Vx is what? Vx is 0 by virtual ground. So II will be equal to minus V naught upon RF. That means RF, that means V naught is equal to minus RF into II. Where what is II? II is the input current and V naught is the output voltage. So, by this circuit we can simply conclude that this circuit is going to convert current into voltage. Just like the amplifier, just like the voltage to current converter which converts voltage to current, and this circuit converts current into voltage. And you can see this negative sign. Yes, this negative sign indicates that there will be a phase shift of 180 degree between input and output. Whenever we will get this negative sign in operational amplifier, we can simply conclude that input and output will be out of phase, or we can say there will be a phase shift of 180 degree between input and output. Now, there is one more important circuit and its name is instrumentation amplifier. As its name suggests, instrumentation amplifier, that means it is amplifier, but generally it is used in instruments. That means this is used for practical purpose. A practical purpose amplifier means the amplifier which can provide good amount of gain, and there should be a good capability to reject noise. That means CMRR should be very high. That means noise rejection capability should be high. So, an instrumentation amplifier is one kind of IC mainly used for amplifying signals. The amplifier comes under the family of the differential amplifier. The main function of this amplifier is to diminish surplus noise that is chosen by the circuit. The instrumentation amplifier is essential component in the designing of circuits due to its characteristics like high CMRR, open loop gain is high, low drift as well as low DC offset. Instrumentation amplifier is used for amplifying very low level signals, rejecting noise and interference. Examples can be heartbeat, blood pressure, temperature, earthquake, as well as there may be some other kind of signals. Therefore, the essential characteristics of good instrumentation amplifiers are as follows. That means it will have very low signal energy. So, to overcome this, that means to get sufficient amount of output, gain should be very high and it should be accurate. Accurate means the effect of noise should be minimum. That means CMRR should be high. Its slew rates should also be high to handle sharp rise times of events and provide maximum undistorted output swing. However, there are more than 2 to 3 types of instrumentation amplifier, but this is the most popular circuit of instrumentation amplifier. So, now let us analyze this circuit. One operational amplifier is connected here, second operational amplifier, and this is the third operational amplifier. Okay. This is used in non-inverting mode, this is also used in non-inverting mode, and its gain will be 1 plus R2 upon R1. Its gain will also be equal to 1 plus R2 upon R1. This is VI1, that means input 1, this is input 2, and this amplifier is used in the differential mode. It will amplify this signal which are the output of operational amplifier 1 and operational amplifier 2. So, for its analysis, or I can say to simplify its analysis, we can redraw this circuit like this. These two resistors are in series. So, it will become 2R1, this is I1, I2 and remaining things are same. So, now let us analyze this circuit. See, so see what will happen. This is Vi1. By virtual short circuit concept, this voltage will also become Vi1, Vi2. Now see, input 1 minus input 2 is nothing but differential input voltage, that means VID. And what current will flow through this circuit, through this resistor? If I am considering the direction of current as this, that means Vi2 minus Vi1 upon 2R1. So, this current will be equal to Vi2 minus Vi1 upon 2R1. And Vi2 minus Vi1 is what? It is VID upon 2R1. So, this current will be VID upon 2R1. Now, this same current will flow here. This same current will also flow here. Okay, see, because no current is going inside this, no current is going inside this, so this same current will flow. Now, see, let us analyze this circuit. Actually, I actually want to find out this VID, that not VID, but the voltage difference between these two. So, now you can simply apply KVL. This voltage plus this voltage plus this voltage, see, minus plus, plus minus, minus plus, if you will do it, then you can find out very simply that this voltage or the voltage between these two will be VID 1 plus 2R2 upon 2R1. Okay, where 2 and 2 will be cancelled out. So, it will be this. So, V0 will be, now this is the input which is coming between these two terminals. So, if you will observe this, then this is nothing but this is differential amplifier. And what is the gain of this circuit? R4 upon R3. So, V0 is equal to R4 upon R3, VO2 minus VO1, and what is U2 minus VO1? This is 1 plus R2 upon R1 into VID. So, now what is AD? AD is, that means differential gain. Differential gain is what? AD is equal to, differential gain is equal to output upon differential input. That means V0 upon VID. So, take it to that side. So, V0 upon VID will be this, R4 upon R3, 1 plus R2 upon R1. So, if 2 R2 are not same, that means if these two resistors will not be same, then we can take one as R2 and another as R2 dash. Rest everything will remain same. Now, see how it will provide more gain. One factor is this 1 plus R2 upon R1. By choosing proper values of R2 and R1, you can achieve the desired gain. If you want somewhat more gain, then you can again choose the value of R4 and R3 to get more gain. For example, if you want to achieve 200 gain, then This factor should be selected as any, like 20, again it should provide 10. So 10 into 20 will be 200. If you want 400, 20 into 20. If you want 500, 25 and 20, whatever you want. So this circuit can provide more output, or I can say this circuit is providing more gain. Now, how does this circuit is providing more noise rejection capability? See, even a single op amp has ability to reject noise. So first, noise will be rejected at this stage. Even some noise will come, then again that noise can be rejected by this amplifier. There are two stages for the noise rejection, and its common mode gain is 0. So we can say that its CMRR is very high. So this is what which is known as instrumentation amplifier. In next class we will discuss filters. Okay, thank you.